All right, here we are with our Intro to CAD class. Today we are going to be taking some of your files, like your motors and batteries and such, and bringing them into a CAD assembly to start building our chassis. To get started, we have a folder already created, ready to go for BattleBots in your drive. Inside of that, I've got a parts folder that I've downloaded some of those parts off of the internet that we have talked about. So the motor's there, the battery's there. I can even get some wheels into this location eventually downloaded for what we need to do, and I'll be putting all my files just in the main BattleBots folder. We have Inventor open, ready to go. So we're going to start a new file in Inventor, standard IPT, to go ahead and get started with that process. I'm going to start by drawing a basic chassis for us to get going with. And so we're going to go new. Come on, stop. Going to go to new, start on a sketch. We're going to create a rectangle for now. And I'm going to create something that, and maybe you have a sketch already to go, which would be great. I'm going to go 6 by 4 inches to get started as a size. I don't necessarily have a sketch for mine per se. So I'm going to start with that size. I'm going to finish that and extrude that maybe, where'd my window go? 2 windows here, my apologies. 1/8 of an inch to get started. And I kind of have a base plate ready to go. I'm going to save that as my chassis to get started with, just so I have something going into my Intro to CAD, BattleBots. I'm going to call it Chassis 1, because there's a good chance I'm going to be doing multiple chassis versions until I get this right, so I can call it Chassis 2, 3, 4 down the road. Chassis 1 save. I now have that in here. So in my drive, I have the Chassis 1, and I have my various parts ready to go. I'm going to now go to an assembly, so new standard assembly file. We've already done this with a previous assignment, and I'm going to bring that chassis in. Tech Ed, classes, Intro Bots, chassis. And I've got my first part in here called Chassis 1. I want to ground that just like you did with your previous assignment. When things are in motion, we want to have at least one thing grounded. So I always like to ground the first thing that I bring into a file. So we've got our basic chassis. It's not going to stay that. I can come back in here, and as you already know, if I for some reason came in here and made a change to this chassis, which I would not do this, that updates in the assembly file. So we can keep making changes to our parts, and they will update as we go forward. So that's a positive. In the assembly file, I want to start bringing in some other things. So I'm going to bring in the motors. So I'm going to go place, go into my parts, and I'm going to bring in the Gecko motor, which is what we're using, open. And because it's a step file, STP, not necessarily an Inventor file, it is a CAD file, different type. It forces this window. It says, hey, how do you want to bring this in? I usually just say okay, and it brings stuff in just fine. I want 2 copies of the motor, hit escape, and I've now got the motor in the assembly file ready to go, which is great. I'm going to go ahead and start constraining this motor to the chassis to get started, just to start figuring out some sizes here. So I want to rotate just a little bit. Both sides have the logo, so it doesn't really matter what size I use. I just wanted to make sure I could still see it for what I'm doing. I'm going to come in here and make sure I get that flat surface. Click on there, apply. I'm going to drag it over here for now and do that again. Constraint, get the flat surface on here, apply. I need to rotate these both around, so I'm going to come in here and constraint, flush this time. That front face for now to this edge of the chassis, apply. It can still move this way, that's okay. I'm going to constraint this other one same way, just to kind of get it into a place. This is absolutely not where it's going to end up, and that's okay. I also want them to be in line with each other, so I'm going to go flush this edge of the motor to that edge of the motor, which straightens them out. They can still go up and down. So I'm going to do an offset constraint, flush here to down here, and I'm going to say 1 inch, 1.5. I'm just picking a value for right now. Apply, and I've now got my motors locked on to that pan. Very simple. Obviously not my chassis yet, but I can start pulling things together. In all reality, I should probably turn these the other way, probably. This is the long way. I think I meant to go the other way, so seeing as I did not catch that, I'm going to delete this one, and I'm going to go delete this one quick, and I should be able to just change my flush constraint from here to here. No, didn't like that. Alright, let's delete another one in here. What do I need to delete? Let's delete this. No, it's this one. Delete. Okay. Constraint, flush. Here to here. Changes those, apply. Do I have room to do that over here with how big my chassis was? So constraint, flush. So I just changed the two walls that I was connected to, running them there. I still have room to get my wires in between. They still go together, so I can go ahead and do a flush constraint now. So you can see it's pretty common to make some changes as you go. Let's make that 1.5. Apply. All right, so there we go. We have that. We're going to hit save on this and call it bot 1. In case I make changes to this bot, and we now have this assembly saved. If I come back to my chassis and I say, you know what, I don't need it to be this long, go back into my sketch and change this to 5 inches instead of 6, finish and save. When I come back here, it actually shortens up my chassis. Wasn't hugely noticeable, but it did shorten the chassis a little bit for that process. So we can still make changes to the chassis as we go. All right, I want to see height of wheels. The only way I'm going to know height of wheels is bring in the wheels. So I'm going to go ahead and place, and I'm going to start with a smaller wheel here, 1.5, open, place, and I'm going to go ahead and start constraining those. I've got an axis and a hole, so if I come in here and grab the axle where it shows me this center line, and I do that in the hole where it shows a center line, and actually plops them onto each other. I can do that for this other one right away. Apply. They can still go back and forth. So I'm going to go ahead and do a flush constraint for now. Flush there to there. Apply. Rotate a little bit over here. Come in and do the same thing there to there. Flush. Apply. And my wheels are in place. Obviously there would need to be a hub holding that wheel onto the axle. If I go place, you'll see that I actually have that hub drawn. That's what would go onto the axle. We don't need that for the purposes of right now, for trying to figure out some sizes. They don't necessarily need to be assembled onto that drawing. So we got some wheels on the motor. If we need bigger wheels, we'd have to delete them and put them back on. But let's go ahead and take a look. So right now, if that's where the motor was, does my wheel have ground clearance to the ground? Yes, it does. Do I want that much ground clearance? Probably not, because again, if you can get another bot under you, well, they have a chance of lifting you or throwing you. So we probably want a little bit of ground clearance, like an 1/8 inch maybe. Not much more than that typically. So how do I, 2 ways to get less ground clearance. Throw an idea out there. How can I get less ground clearance? Motor higher or smaller wheel. I'm going to make the motor higher. I think that's a better choice. Gives me a little bit more meat to make a mount for the motor anyways. Right now there's really nothing to mount that motor with that design. So I'm going to come in here to the motor, over here to my constraints that I had, and I'm looking for the one that I constrained it to the deck of the chassis, and I'm going to give it an offset of maybe 0.25. That just raised that motor. I'm going to come back and look. I've still got some ground clearance. Actually looks about an 1/8 inch. Maybe I want a little bit more than that, so I'm going to come in here and change that constraint to 0.2. So there is raising the motor a little bit. I'm going to do that to this other one also, just so they're the same. 0.2. And now, theoretically, I've got a good ride height for where those wheels are in that location. Now, before I start building a motor mount into my chassis plate, where that motor is going to be locked into place, I definitely want to make sure that motor is where I want it to be. Not that you can't change it, but it's a lot easier the less changes you make in the future. I know if this is going to be a wedge bot, in general, I want the wheels in back as far as I can go so that the wedge is always on the ground. Think about it. If I put these wheels in the middle of this plate and I drive, what's that bot going to do every time I drive forward or drive backwards? If they're in the middle of the robot, it's going to lift up, right? Like a teeter-totter. Every time you go, it's going to want to cock up on that. But if I get those wheels all the way back and you got the weight forward, less of a chance of that thing doing wheelies as it drives. I'm not saying it can't, but less of a chance. So we're going to find the motor again and which constraint I had the flush offset to the back right there, 1.5 inch. I'm going to say 0.75. I'm going to maybe look at a top view and kind of get a judgment call here. If I put all my electronics up front and I have just this back here, I need to have a motor mount, that's probably pretty safe. I might be able to get away with 0.5 instead of 0.75. I'm going to go ahead and do that just out of curiosity. 0.5. I'm going to try 0.5. I may have to adjust that later, but I'm going to say that's where I want my motor to be. I'm going to save this assembly, and now we have that saved for what we're doing. All right, couple of ways that we can mount things to what we're doing. We can use these holes here to have a wall come up and grab it, or we can use the structure to bolt down to it. I want to try to show both ways. Video is going to get a little bit long, but I think it's important to show these two steps. This is really the last two things I want to show, is how we can use this geometry in assembly. So on this wheel here, I'm going to take that flush mount to the outside wall, and I'm going to set it in by 1/8 inch, 0.125. So I just moved that one in by 1/8 inch, giving me some wall height to play with. What does that mean? Okay, we're going to come into the chassis, and I'm actually going to close this file. The reason I'm going to close it is if in the assembly I double click on a part, I can now edit that part from the assembly normally. So the motor I've changed from the assembly file, and I now have my drawing files in my history browser showing up. I could edit that file. But if I click on a file that's already open, like the chassis is already open as an IPT, it goes to the IPT. So I don't want that to happen right now. I'm going to make sure it's saved. I'm going to close the IPT. And now in the assembly, when I double click on the chassis, I'm working on the chassis in the assembly file. There's a lot of wins to this. There are some negatives that can get you in trouble. I'm not going to worry about those too much right now. There's a lot of wins to this. Okay, so I want to put a wall up over here. So I'm going to sketch on the top of the chassis. I'm going to draw a rectangle wall for right now. And I'm going to make sure I'm all the way over to the edge. Tab, 0.125 inch thickness on the wall. Finish. I'm going to extrude that wall up, I don't know, 2 inches, which is more than I need just to get the point across though. When I rotate and look at it, that wall now goes up past the motor, more than I need it to. I don't want it to stick above the wheel technically, so I'm going to go to a side view here, and I'm going to go to my extrusion, and I'm going to say 1.5, still too tall, 1.25, that's as tall as the wheel, 1.05, nope, 1.15, that looks pretty good. I've still got wheel sticking above the wall, so if I were to flip over, I could still drive. Okay, so there's the height of the wall. I could do that by looking at the wheel in the assembly to know that I can do that. Okay, here's the next advantage. Again, we have an assembly, so the motor is there. That motor has 4 bolt holes that you can bolt to the flange of the motor. We need that geometry on the sidewall. So if I come and sketch on the sidewall, I'm now sketching on this surface, and I go to project geometry, I can come in here and find things I want to pull forward. I'm kind of taking a guess as to which holes I need right now, because there's a lot of holes right there. So I am going to come over here to this other motor, which should be the same thing, and I'm going to turn, I'm going to go back to the assembly. I'm going to turn this wheel off, visibility. I'm going to go back into my chassis, back into my sketch, project, and I'm going to do it from this other motor. So the mounts that I want is this hole, this hole, this hole, and that hole is my 4 mount holes to my knowledge. When I come around, you'll see that we pop those holes into that sidewall. So with that done, I can now finish, extrude, cut, and I now have those 4 bolt holes that I can grab to the motor to bolt through that wall. I didn't have to sit and measure and get those holes perfect. I didn't have to look at a blueprint of where those holes were. I pulled them right from the CAD model. Assuming the CAD model that I gave you is accurate, it pulled that information in. Now there's some other things about that setup. If we take a look at that motor, so let's go ahead and finish, return. If we look at that motor, there is a flange right there. So I could also extrude cut that flange into the sidewall, so this actually sits flush if I wanted to. And I need a hole for the axle to stick out as well. So there'd still have to be some more geometry done to that wall for the motor, but essentially what I just did was locked that motor into that wall. So that's pretty cool. It's one way to do it. All right, we need to save, because that chassis file is not saved yet. Save. Make sure they all say yes and okay. And now that chassis file is saved with that information in it. If I go open the chassis in the correct folder here, classes, intro to CAD, chassis 1, it's got those holes in it. All right, second way you could do a mount is making a 2-half like eggshell that would bolt onto this thing to hold it in place. I'm going to do that around the motor here next using the square part of this motor. So again, I'm going to double click on the chassis. I'm going to sketch on the top. I'm going to use project geometry to grab that, and I want to get this geometry here of where I can't grab to. Finish sketch. And I have now placed, it's kind of hard because it's got an optical illusion going on there, but I took that geometry and put it down on the chassis. Okay, so now I can come, still in the sketch. No, I'm not. I got out of it. There's the sketch. I'm going to now take that information and I'm going to come out here a ways and out here a ways and make a rectangle. I'm going to dimension that rectangle right now to be 0.375 away from that direction, 0.375 away in that direction. Finish. I'm going to extrude that to the bottom of the motor. I can choose this to button instead of a distance, and I can choose the bottom of the motor. Okay, and I've just sent up a block to the bottom of the motor. I'm going to re-sketch on that block. I am going to re-project some geometry to grab there, and then I want the block. And because it did that, I have my squares. Finish, extrude. Should have let me grab. All right, I got to make a square there first. Rectangle here to here, here to here. Finish. Extrude that, and and I want to come up halfway. I got to figure out what halfway is. So I'm going to finish. I'm going to take a measurement. If you haven't done measurements yet, inspect, measure. From there to the bottom is 0.65. So if I go back into my chassis, go back into that sketch. I don't need the sketch. We're going to extrude. Come on, grab the right thing. Extrude that and that. 0.65 divided by 2. Return. And we have just drawn half of a motor mount that can help clamp around that motor. What does that mean? If I hit save and I open the chassis file, you can see that we've started to create a block that's going to sandwich the motor. That's a part of the chassis. Okay? We need a duplicate top half of that. So I'm going to take a couple of measurements, inspect. So inspect, measure. This is 0.409. From here to here, 1.4. Measuring total height, 0.505. So I'm going to start a new file here, standard IPT. Start a catch, rectangle, 1.404 and 0.409. Finish, extrude, 0.505 tall. I'm going to go make sure that's what those measurements were one more time. So height was 0.505, width 409, and length was 1.4. All right, so this here is 0.375 in each direction, and it is 0.325 deep. So I'm coming here, sketching on the top, drawing a rectangle, and measuring from here to be 0.375. Here to be 0.375, and I need to extrude that cut. I don't remember how far. Measure 0.325. So finish, extrude, 0.325, cut. And there is the mate of that file. Now, technically, if I want these two halves to sandwich tight on the motor, should I have the depths be the same depth as the motor, or a little less, or a little more? Theoretically, it should be a little bit less of the size. That way it actually clamps down. So I'm going to take that 325 depth and make it 320. That way it gives it tight when it comes down on the clamp. I'm going to save this as top motor clamp 1 into my folder where all my stuff is. I'm going to my assembly file. I am placing top I don't see it. Where did I put it? File, save as, classes, BattleBots, top motor clamp 1. Save. Yes. There we are. Top motor clamp 1. Open. 2 copies of that. I'm going to go ahead and constrain that part in here. So I'm going to say this is going to there, apply, flush, here to here, apply, flush, here to here, apply, cancel. We're going to just set that one aside. Those 2 clamps are there. How are we holding those 2 clamps together? Right now, are we? No. How could we hold those 2 clamps together so they actually stay in place? A number of right answers. Screws, probably the easiest answer to do. Right? We could glue it, but then we'd never get it back out. We could use zip ties, put a channel in there and zip tie it. Probably a bunch of different ways we could do it. So if we're going to screw in here, we can then start creating some holes to put those screws in. I think I'll do that in a later video for us versus this one's already getting pretty long, 25 minutes. But from there, we could theoretically start holding those 2 parts together, put the motor in, put the clamp down, screw it down, you've got a motor mounted. So we've shown 2 different ways to put a motor into your chassis using an assembly file to get your information. One is using the flange mounts, one is using a clamp mount. There's probably other ways to do it as well, but those are two pretty simple ways and how to do them in CAD. We want to make sure that we continue to hit save from assembly files when you're working this way, because that also saves the individual IPTs often, but it's also safe every now and then to go save those IPTs as we go. If you're like me, one last little tip and trick, I do like to show different parts in different colors. So I'm actually going to go to my top motor clamp and change the color here to be gold. Save. And now we start to see those popping in that assembly, which is nice to see things. I can turn my wheel back on by coming over here, right-click visibility. It brings it back into play instead of it being invisible to us. And that wheel is there. So hopefully this does help you start to create those designs.